Hi, my name is Joshua Slack, and you're watching the second video of the Ardor3D Left 4 Dead hobby series. Now, last time we went over a little background as to the what and why of this project, so now let's get into the how. Roots on this project actually go back to the end of 2005, when I worked on porting an existing Quake 3 importer as a way to compare the older JMonkey engine to the other Java engines of the time, such as Java3D and Zith. Now, the project lay dormant for a couple of years, and then David and I decided to go back and revisit it. And it turned out the graphics felt a little too dated to use, so we went to the aforementioned Left 4 Dead. Left 4 Dead is based on the source engine from Valve Software, and there's a lot of information about it on their developer wiki, as well as in the source SDK itself. So we took all this information, and we got our start by just loading in the basic map geometry. The Left 4 Dead map format is based on binary space partitioning, or BSP, and is a series of nodes divided into geometry faces and further arranged in clusters. Now, this isn't too different from the Quake 3 format, so we're able to get geometry loaded in very quickly. With geometry conquered, we quickly moved on to texturing. Now, Valve has their own file format called VTF, which essentially takes any texture type, cube maps, two-dimensional textures, and so forth, along with their MIP maps, and stores them in their native format, all in a single type of file. Ardor3D's image system is designed to be pluggable, so we put together a Ardor3D plugin for VTF files. So you can see here with just the base texture applied, we're already starting to get a glimpse of the original Left 4 Dead game. In fact, with the higher quality textures and geometry, it's even starting to look better than the Quake 3 importer that we had before. The only thing that we're missing that we had with the Quake 3 importer was lightmaps. Now, Valve's BSP format actually has both standard range and high dynamic range, or HDR, lightmap information. Left 4 Dead seems to only use the HDR versions. What this means is that the lightmaps actually have pixel color information where the color is outside the normal range that your monitor can display. The format that Valve used for this HDR information is called RGBE. Here's some code showing how we convert from RGBE to floating point colors. Basically, we take the E value from the end and go 2 to that power and multiply it by R, G, and B individually. Alright, so for the last part of this video, let's take another look at the level, this time with the light maps turned on. You'll notice that with the light maps turned on, things look extremely blown out, or in some areas they might be extremely dark. And this is because, as mentioned, the HDR light maps are colored outside of the range of your monitor. And so you actually have to use a special technique to bring the colors into the range of your monitor. Now, at this point in the development, we actually didn't have time to do the HDR conversion, so what we did instead was we turned on vertex lighting, and as you can see here, that dimmed down the faces enough so that it wasn't quite as much of a distraction while we worked on other areas. Well, that's about it for this episode of the Ardor3D Left 4 Dead project. I hope you'll check us out next time when we'll load in occlusion information, models, and we'll cover HDR lighting and tone mapping. We'll see you next time.